Hello, algebra students. This is a lecture on adding and subtracting polynomials, but more specifically, it is our introduction to polynomials. This is a term that we have not used all year. We're going to be introducing it in this section, which is section 8.1. Let's start with what a monomial is. So what we're talking about today is polynomials. First definition is going to be monomial. A monomial is a number. A number would be something like 3 or 5 or -5 or something like pi even or 2.1, okay? A number, a variable, something like x traditionally, or the product of a number and a variable, something like 3x, right? Product meaning multiplication. So a number, a variable, or the product of a number and a variable. And the variable may have whole number, like 0, 1, 2, 3, etc., exponents. So it could be 3x, or it could be something like 3x to the fourth. Each of these things is a monomial. So what we're looking for is a number, a variable, the product of a number and a variable, or the product of a number and a variable that may have whole number exponents. It's worth noting, I think, that this is a whole number exponent, right? If it's just x, this has an exponent of 1. And if it's just a number 3, we could think of this as 3x to the 0th power. Because remember, anything to the 0th power is 1. So in red here, this is just 1, and 1 times 3 would just be 3. So any of these is considered a monomial. Mono, of course, means 1. You guys should know that prefix, mono meaning singular and poly meaning many. So when we talk about a polynomial, all we're going to be talking about is many of these, multiple of these, right? So a polynomial is either a monomial, like these, or the sum of these. So we start adding them together. And then if we have a bunch of these added up, let's say we were adding all of these up, that would look like 3x to the fourth because we like their exponents to be in decreasing order. So that'd be 3x to the fourth plus, we'll say 3x plus 3. Okay, this is an example of a polynomial. This is a monomial, this is a monomial, and this is a monomial. And we are going to be adding these together, or we could be subtracting them as well. It could be -3. This would be another example of a polynomial. This polynomial right here has 3 terms. This is going to be considered a term right here. This would be considered a term, and this would be considered a term. So this is a 3-termed polynomial. I already mentioned this, but standard form, we like these terms to have decreasing exponents. So this one has an exponent of 4. This one, if it had an exponent, if we listed it, it would be 1. Right? We don't need to write that 1 there, but it does exist. Its exponent is 1 here, and the exponent on just -3 is 0. Does not have an exponent. But you guys are going to be charged with, you guys are going to have homework problems where you're writing the polynomials in decreasing exponent order. Biggest exponent on the left, decreasing exponent as it goes. The leading coefficient of a polynomial is also something that you guys are going to have to come up with. And to find the leading coefficient, first put it in standard form. This one here is in standard form because the exponents are decreasing. And then it's just the first coefficient. And a coefficient is just the number in front of a variable. So I know that all of these are the number 3, but right here, this is the leading coefficient. Okay, it's in standard form, and then it's the first coefficient, the first number in front of the variable. You guys are also going to be having to find the degree of a polynomial. And the degree of the polynomial is the biggest exponent. So in this problem, the degree would be 4, right? Because that is the biggest exponent. It's the exponent on the one with the leading coefficient, right? This is the leading coefficient. The exponent on the variable is 4. So because this is the first section of a chapter, there's a lot of vocab that I'm throwing at you. And this is completely new vocab to you guys. You guys are not familiar with any of this. So make sure you understand these. Once again, a monomial is a number. like 3, a variable like x, or multiplying them together. And oftentimes our x is going to have whole number exponents, like 0, 1, 2, or 3. Notice it cannot be a fraction exponent. It cannot be a negative exponent. Those would not be considered monomials. A polynomial would be adding or subtracting a couple monomials together. In standard form would be when our exponents are decreasing. That's nice. The leading coefficient is the first coefficient when it's in standard form, and the degree is the biggest exponent that is in the polynomial. So here's a perfect example of a polynomial, right? It has 3 terms, 1 term, 2 terms, 3 terms. It is in standard form right now because the biggest exponent is to the left, and then this one has an exponent of 1, and this one has an exponent of 0. The leading coefficient would be 3, and we get that from here. This is the leading coefficient. And its degree is 2. And its degree is 2 because that is the biggest exponent that exists in the problem. So your first homework set, basically one problem asks all of these different questions. Is this a polynomial? And they're going to get a little bit maybe more difficult, like this one. Is this a polynomial? Are we allowed to have 2/3 or a fraction as a coefficient? Okay, let's look at this. A monomial is a number or a variable, or the product of a number and a variable. This is the product of a number and a variable. And it has to have whole number exponents. So the exponents have to be whole numbers. The exponents cannot be fractions, but the coefficients can be. So I think a lot of you guys would have said that this is not a polynomial because it has to have whole numbers. Remember I wrote 0, 1, 2, 3 on the last slide? Those have to be in the exponents. It can have coefficients that are fractions. So yes, this is a polynomial. It is not currently in standard form. You guys would need to be writing this in standard form. Standard form would be 2x, 2/3 times x to the third. That's the biggest exponent. Next biggest exponent is this one here, and that's a positive 5x squared. Then a positive 2x, and then a negative 3. The degree of this polynomial is the biggest exponent, that's 3, and its leading coefficient would be 2/3. This is kind of a weird one. Is pi a polynomial? Well, is it a number, a variable, or the product of a number and a variable? It absolutely is. It's a number, right? So once again, the exponents have to be whole numbers. The exponents cannot be fractions, but the coefficients can be. So yes, this is a polynomial. It's already in standard form. There's nothing we can do to rearrange it. What is the degree of this polynomial? What is the biggest exponent? Well, this doesn't have a variable at all right now, right? But pi is the same as pi times x to the 0th power. How do I know that? Well, what is x to the 0th? X to the 0th is just 1, and pi times 1 would just be pi. So its degree is actually 0, and its leading coefficient would be pi. As the title suggests, add/subtract polynomials. That's not going to be the only task we're doing, is just rearranging it and identifying those terms. You guys are going to have to add or subtract a polynomial with another polynomial. That's going to be kind of your main task. That's the main takeaway from section 8.1. Just like growing up in elementary school, first you learn to add, then you learn to subtract, add whole numbers, then you learn to subtract whole numbers, then you would multiply them, then you would divide them. That's the same thing that we're going to be doing with polynomials. First, we're going to learn to add and subtract polynomials. Then we're going to start talking about multiplying polynomials. And dividing polynomials doesn't happen until Algebra 2, so you don't have to worry about that one right now. So we have a polynomial in red and a polynomial in blue, and we want to add them. Here's what I'm going to tell you about adding polynomials. You can basically, if you're adding, and this only works when you're adding, forget about the parentheses. Okay? When you're adding polynomials, forget about the parentheses and now just combine the like ones. So 5x to the third and 3x to the third. When you are adding and subtracting, combining like terms, that type of thing, you're looking for the variable x and the exponents to match perfectly, and then you just add or subtract the coefficients. So 5x to the third, if you have 5x to the thirds and you add 3x to the thirds, you would add their coefficients to make 8x to the thirds. These ones are like because it's x to the third and x to the third, and then you just combine the coefficients, 5 and 3. Up next, after x to the third would be x squared, and this one doesn't have any partners. We don't have anything to add with negative 4x squared. So it's just going to be negative 4x squared here. Up next would be plain x with no variable, or no exponent, sorry. That's just going to be plus 2x. And then we would add the things without a variable. We have a positive 8 and a negative 4, which would make positive 4. And that is our answer to adding or subtracting this polynomial here, right? The polynomial 5x to the third minus 4x squared plus 8 plus 3x to the third minus 4 plus 2x. Okay. Notice this one wasn't in standard form, but we just added it. We want to make sure our final answer is in standard form, and it is now. So here's the next example. We want to add this polynomial with this. However, this actually isn't a polynomial. It's a trick question, right? We are not allowed to have exponents that are negative or fractions. And this one does have an exponent that is negative. So if you were asked to add these polynomials, I'd say nope. This is not a polynomial, right? This one here is not a polynomial. This one is, but 3x plus 2x to the negative first, you are not allowed to have negatives in your exponents. So let's try this one again, but with an actual polynomial plus a polynomial. Here's one polynomial, and we're adding it with this one. Go ahead and pause it here, try it out, see how you do. I'm going to go ahead and solve it right now. This one here, that's going to be our biggest exponent is to the third, but it doesn't have any partners in the other one. There's no other x to the thirds. So our leading coefficient, our leading term is going to be negative x to the third. Up next, we have x squared. We have a positive 2x squared here and a positive 2x squared there. When you combine those, they make positive 4x squared. Up next would be plain x's. This one, negative 3x and a positive 3x. Negative 3x and positive 3x, they cancel each other out, right? Negative 3x, negative 3 plus 3 would be 0x. Okay, it's canceled out. So I don't even need to worry about that. And then we have a minus 1, and this one doesn't have any partners. There's no number without a variable here. So that would be my answer. Let's then look at some subtracting problems. Okay, here we want to subtract, we want to take a polynomial and subtract this polynomial. Now remember what I said, when you're adding, you can pretend like the parentheses don't exist. But when you're subtracting, you can't do that. I think it's worth noting that this polynomial here, the first one in parentheses, doesn't have a negative sign in front of it. So this one here we're not going to change, but this one here has a negative sign in front of it. And so what you guys need to do is you guys need to distribute that negative sign to everything in the parentheses. Okay? When you're subtracting, distribute the negative to everything in the parentheses behind it. This is the thing that's being subtracted. So it's actually going to be minus 3x and minus 2x squared. You see that? I took this negative and I applied it to the 3x, making it negative 3x, and I applied it to the positive 2x, making it negative 2x squared. This one didn't have a negative sign in front of it. So I don't need to distribute any negative to it because it didn't have one. This one here, I can just get rid of the parentheses. And now I'm going to combine them, just like in the last problem. I'm going to look for which things are like. The negative x to the third doesn't have anything that's like it, so negative x to the third is going to be in my final answer. Up next would be x squared. I have a positive 2x squared and a negative 2x squared. These two are like. Positive 2 and negative 2 make 0, so they cancel each other out. Up next would be just plain x's. Here's a negative 3x minus 3x. What is negative 3x minus 3x? Hopefully you're saying negative 6x minus 1. Final answer. If you were asked to come up with the degree, I would hope you would come up with 3. And the leading coefficient, I would hope you'd come up with negative 1. Okay, negative 1 is leading coefficient because the number here, if it had one, would be negative 1. Let's do one more subtraction problem. Pause it here, see how you do, and then that'll be the end of our lecture on section 8.1 today. So hopefully you guys are remembering that this negative sign needs to be applied to everything behind it. So this would be negative 3x to the third. Negative 4 actually makes this plus 4, and distributing that negative to the 2x makes it negative 2x. This first one doesn't have a negative sign in front of it, so I can just copy it down without applying a negative to everything. And then from here, I just combine my like terms. 5x to the third and negative 3x to the third makes 2x to the third. Right, because 5 and negative 3 make 2, and then the x to the third's, like, that doesn't change. Negative 4x squared doesn't have any friends, doesn't have anything that's like it, so it'd be negative 4x squared. Up next would be the plane x, and this one doesn't have any partners either, so it's just minus 2x. And then a plus 8 and a plus 4 makes positive 12, and that would be our final answer. So this is our lecture on section 8.1, which is about adding and subtracting polynomials. Please let me know if you guys have any questions.